Hello everyone, welcome back to Advent of Code. We're going to be starting in a moment, or a few moments anyway, on day 2 of 2023. But as I often do in these Advent of Code series, I wanted to start with reviewing yesterday's solution, or yesterday's puzzle, I guess, and also my solution of that puzzle, and look at a couple of changes I made overnight. I made 2 changes. We can see, I guess I can even... Okay, never mind. Scrolling sucks. So, but here we go. This is how I can make you see this. Actually, can you see my mouse cursor? No. Okay. So one I made myself, which I don't think was that interesting, was I just inlined some, not inline, but like public module level functions that were only used once, or values that were only used once. I inlined them into where clauses in the place where they were needed, which seems a little cleaner, but I don't know, maybe not. I mean, this is the one that I actually think was useful. I mean, we can look at both of them, right? So here's the like, inlining or moving stuff around, right? Guarded by and calibration value were only used once, so I put them in one place the place where they were used, and then digits was only used once, and that sort of gives you a better idea of the amount of space taken up by part 1 and part 2, sort of. But the one I actually like was this one, which was suggested in a YouTube comment by someone who also mentioned in a YouTube comment that they're just learning Haskell this year, so well done spotting that. I don't understand. So first of all, don't re-implement asum is basically what I would describe how I in fact do describe this commit. I had this thing where I had a list of maybe, or I wanted to map a function over a list, and that function was going to produce a maybe, and I wanted like the first value, the first just produced by that function when mapping over that list. And I was like, okay, this is kind of a monoidal operation, right? Where we have like, maybe A really should be kind of, you can take a monoidal view of maybes, and so I'll map. But like you have to wrap in this new type wrapper first so that it knows which way to bias, and that you don't want to combine the monoids inside the maybes. You want the maybe shell itself to be the monoid. So anyway, I had to map first and then call mconcat to get the monoidal thing to say turn a list of monoidal thingies into just one monoidal thingy, in this case by taking the leftmost, and then call get first to convert that to a regular maybe. So I did that. But asum is what does exactly that by viewing maybe not as a monoid, but as an alternative. Alternative being like a type class for things that let you consider multiple options, sort of. So asum takes a list of maybe A and produces a maybe A. And what really puzzles me about this, well, first of all, like I've used this before, right? In previous years, so I just had a blind spot, couldn't remember what it was. Thanks to be announced for reminding me. But what I don't understand is I did the Google search you're supposed to do, right? So if we look on Google, we can see what is the type of asum. It takes a foldable containing alternatives and gives you just one alternative. And that's exactly what I want. But if you let T be list and F be maybe, then, this should have the signature maybe A, maybe A. And this is the Google search I did. And I didn't see anything in base, and it was just like all these weird things that people are implementing themselves for, I'm not going to depend on dbus to get this function or whatever, right? Or fuzz check. And I don't even know why it's telling me about concat. I guess does maybe have a vector instance? Maybe. I guess it must somehow. I don't know what vector really does. So I did this Google search and it doesn't find me the answer, and I don't understand why. Because if we let, as I said, instead of you see what's our foldable? It's lists. What's our alternative? It's maybe. This is the type signature that asum has. And, just in case you don't believe me, we can look here and say, reload first. What is the type of asum? And by the way, I want that type to be maybe a, and it'll say, yep, that sure is the type of asum. I had to specify here because if I just ask the type of asum, it'll say, oh, it's this, which is fine. But I wanted it more specific. And just to prove we're not cheating here, like, this is not, if you enter something that's not the right type, it'll say, sorry, I can't give you the type of asum as that because it's not the same. But you can tell GHCI how you want the types unified. And it'll confirm for you that that's a valid way to do it. And I thought that was one of the big things Google does, was it searched through, like, the type variables in functions and found a way to unify your query with a function, an existing function. So I don't know. I asked in the functional programming Discord an hour or so ago. And I see there's now a reply where someone's just, I said, well, how come Google didn't tell me? I thought that's what Google was supposed to do. And then someone just said, like, this is the type of asum. And I don't understand if they were trying to answer my question that way or if that was part of their search for the answer and they didn't find it yet. Anyway, so those are the changes that I have made. And, of course, we can just double check that when we stack run, we get the same results. Good. I already did that test. Whoa. Oh, no. I was confused. Why did we suddenly get, like, a totally different looking thing? I guess this year I don't have all of the amenities. As I said, every year my Haskell setup gets jankier and jankier. I used to have a nice, Git enhanced prompt where it would, like, show you here what branch you have checked out or something, and I was briefly confused because this looks pretty much like what that used to look like, and I don't know. So I haven't set it up in this Linux install, so I don't have it. Anyway, so let's move on. Let's see what's going on with day 2. Day 2, Cube Conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. Good aim. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow, and an elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. To get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. You play several games and record the information from each game, your puzzle input. Each game is listed with its ID number, like the 11 in game 11, followed by a semicolon-separated list of subsets of cubes that were revealed from the bag, like 3 red, 5 green, 4 blue. Okay, got it. So this is a single reveal as part of game 1, 3 blue and 4 red. Then another, which was these 9, 9. And then then he just reached in and could only find 2 for some reason. Anyway, so the elf would like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. 1, 2, and 5 would have been possible, but 13 wouldn't have because it showed 13 greens. No, because it showed 20 red. And game 4 is impossible because it showed 15 blue, but there are only 14. Okay. What is the sum of the IDs of those games? All right, sure. Fair enough. Oh, wait, there's another response. Okay. Someone in the Discord says, patch is welcome, basically. Google's not perfect. You can fix it yourself if you want. Okay, great, thanks. I mean, that's not an unreasonable... I was hoping for something more like, what are the ways in which it's not perfect so you can plan around it. But I guess, like, even just knowing, yep, what you did was supposed to work and it doesn't, the problem is Google, not you. And then separately, if you want to, you can fix Google. Fine. So I guess let's just get started, which is going to involve a few changes. Let's see. Day 2. And I'm going to need to move this GHCI as well. And then I need to move Emacs. I can close this file. Day 2 source. Okay, can we turn off this dang breadcrumbs thing? I need to no, LSP, what is it called? I want to turn off the breadcrumb mode, and I had to search for what it was called before. Oh god, if you just search for LSP blah, okay. What are all the functions in breadcrumb? LSP header line. Oops. There we go. Because the breadcrumbs are not useful when you only have one source file. Okay, back to here, and I want to see AOC input of 2, please. And there's an example. Great. So we have one task we're definitely going to want to do is define data types to represent the input we're getting. And a parser to parse those lines. As always, since we're not aiming for speed here or anything, I spend some time doing domain modeling, trying to get types that, so that the important features of the program, of the problem, are present in some way in the program, rather than just operating at the lowest level you can, like running a regex search over the string and pulling things out. And anyway, we'll see. So, first of all, let's say a data color, we'll need one of those, easy, is red. Actually, should I, what color did they come out in? It doesn't say. They come out in an arbitrary color. Fine. So, red, green, blue. We'll just do it in the traditional, RGB color space order. And let's derive, some classes here just in case they're relevant. Show, or sure. Those will probably all be useful. Although, I wonder... Do I actually want this type? Or do I never need, because I'm envisioning a type in a moment called, pull, right? Where a pull is how many reds, how many greens, and how many blues did you get, right? But if I want to represent exactly 3 of those, then, I kind of need it to have 3 fields. One for how many reds there are, one for how many greens there are, and one for how many blues there are. So I I almost never need to mention the colors by themselves outside of when I'm mentioning how many there are of a color, I feel like, right? So I wonder if it might not... So, like, okay, obviously a thing I could do is, like, say, type poll is map from color to int. We would have to import map, but this would be, you know, a way to ensure that a poll contains 0 to 3 instances of a color, of each color. But that's, I don't know. Maybe this is just the right way to do it. Are maps, Are maps semigroups? I think they are. Data map strict, that's fine. Combine? Actually, hang on. First, let's look at the map type itself. Yeah. I see. It is a semigroup, but it doesn't depend on V being a semigroup, so it doesn't combine. It overwrites when you use semigroup operations, I guess. Okay, but surely there's, I mean, combine, right? We have union with. So, like, you could do union with mappend, for example, to combine two. If I had, like, one map representing how much we've looked at so far and another representing how much has been polled just now, you could combine those into a new what's been seen so far using union with and mappend. But I don't know. It just doesn't seem very pretty to me. I wonder. So the other thing I have in mind is suppose we didn't have a color type at all. Let's comment that out in case I decide I want it. Wrong. I pressed the wrong. That's how you comment stuff out. If I said instead we just have, we never represent the colors directly. We just represent them by assigning numbers to each. So it would be a poll where R, G, and B are ints. Then we could, if we wanted, say instance semigroup poll where and I'm sure this can be derivable somehow, like via converting or implicitly assuming these are sum events or whatever, but okay, we can say poll of XYZ combined with poll of ABC is poll of X plus A, Y plus B, and Z plus C. Like, we could do this and then say instance monoid poll where mempty is poll of 0, 0, 0. So this is basically saying, I don't know. It's like these ints are being treated as a sum, and you know, sum is, we could use sum of int, but I don't know. Every time I do that, I feel bad. It's like using the wrong machinery for. Anyway, it's using way too complicated machinery to save. It's not too complicated. It's just kind of silly. So if we had that, we could do things like, say, you know, if I had a poll of 1, 3, 0, and I wanted to combine it with what I had just read from the game summary of, you know, poll 2, 0, 5, this would give me, you know, a poll of 3, 3, 5. But I don't know about this because it feels gross to not have named colors, right? But yeah, I kind of feel like the map approach is just going to be better. It's pre-built. We don't have to do any of this stupid shit. And it reifies the domain concepts of red, green, and blue. It associates each one of them with a number, which is all I really need. And it has easy ways to combine groups using union with. And it occurs to me now, we're not just going to need to combine polls by adding them, but also by computing their max, right? If we have two different polls, then, like, over the course of... Here, let's go look at the input. Right, this is a poll. 2 blue is itself a poll, and then 3 red is a poll, and we'll combine those with summing, and we'll get a single poll that's, 2 blue and 3 red. Then we're going to look at this big old poll. Oops, that's 2. And we'll combine them by max, saying, well, looking at the 2 of these, I can definitely tell... Well, okay, it's kind of boring, because this one is strictly bigger than the one on the left. But here, if we combine this one, 3, 3... Oh, God, do it in RGB order. 6, 3, 3... No. Yeah, 6, 3, 3 is what this would be in RGB order. With... it doesn't even include the green, but... Combining this with this would increase the maximum blues seen to 4. But the number of red seen would stay at 6 because they're tied. And the number of green seen would stay at 3 because this one, the one we've seen previously, is bigger than the one here, which is 0. And those are kind of the two ways we want to combine these polls, these little snapshots. And so it seems like just using a map is really the right idea after all, I think. Okay, so we want a map. And we're going to be working with a... Maybe we can just say a type poll is a m.map color to int. And then we need to describe our input, sort of, right? And I think it's fair enough to say that our input should really be a list of poll, I think. Because each game... No, is it a list of poll? Oh, no. Hang on. Well, you could view it either way, I think. Because, back to the input, because we're using a map, we could say 2 blue and 3 red. These are 2 separate polls, kind of. And then, like, they're being combined because we're saying they happened at the same time. Or we could say, look, there was just one poll here, 2 blue and 3 red, which is kind of more true, I feel like. And then there's a list of those for a game, and then a list of games, right? 100 of them. Okay. And which of these we choose, I think, is going to depend on what part 2 asks of us, in a way, right? Like, for part one, we could say, you know, the input is a list of games, and a game is a list of polls, and we're implicitly like just going to take what happens at each, you know, in between each semicolon as like we're in between the semicolons, we're going to completely combine like this into a single poll. Or we could say, well, you know what, part two might change what it means to do this. Maybe there's some mistake, and we want to preserve the 3 blue and 4 red as atomically different things. But I guess that's like silly, because we can always like take this whole poll and decompose it back into those separate things if we want. We're not losing information by combining it into a single map, right? I think that's true. So I should, while parsing, take this as a single, as like our atomic unit that we're parsing. A game is a list of those and a game identifier. And the total input is a list of identified lists of these things. So that checking the input remind me, oh yeah, we got to check the game identifiers. Now, they are in numerical order. We could just implicitly say the first one is 1 or something, but that doesn't seem very nice. So what I think I will do is say that we have a data game, which is a game of int and a list of polls. And then our input is just a list of game. I think that makes sense. You know what? Let's go ahead and put let's put enum in here as well, just in case. I don't think it will be a huge surprise if we end up wanting this. Because when we query a poll at the end of a game, we're going to want to know, like, oh, how many reds were there? How many greens were there? How many blues were there? And it would be nice to just have a way to say, for each of the colors in the color list. And I think you actually have to, we kind of want bounded as well. Because I want to be able to say, starting from the lowest color, going upward. I want to be able to say, like, min bound to max bound, right? What does enum actually have? Enum. Okay, wait for the page to load and scroll me to the right place. There we go. Enum from, yes. Min bound, max bound. It's also bounded. Enum. Okay, enum from, so enum is just like ways to go up and down. Yeah, bounded is where you have a min and a max. Okay, fine. Is there a function that, like, I don't know. I just want a function that is min bound dot dot max bound, but I guess I can just write that myself. Not a function, but a value, the range, in a sense. Well, I don't know. Let's ask Google. If A were both enum and bounded A, could I have a list of A? Enumerate. Okay, data list extra. I'm not going to use that. Universe. That's interesting, but we don't have universe. Yeah, I don't think there really is one. Yeah, none of these are interesting. Okay, it's just min bound, max bound, but I assume that's what we would find here. Yeah, from min bound to max bound. If we look, it's just that. So I just thought there might be one of these lying around somewhere nice, but I'll just write it myself. Okay. So the interesting, well, I don't know, part of the interesting part, the fun part, maybe, question mark, is going to be writing a parser here. which in many languages you would probably reach for regular expressions at this point. And I'll do that as well, but I'll use regex applicative, which builds regular expressions in a way radically different to what most mainstream languages do. And it's always fun showing people this, and I don't know. I like it sort of from a conceptual standpoint because it's more composable, right? When you write a regular expression, you end up with like 30 characters of extremely dense, low-level stuff, and it's not reusable at all. And if you look at it again in a month, if you're a regex expert, you'll understand it, but it's not easy. And if you're not an expert, you'll just give up, throw it away, and start again if you need to make some change. Whereas using applicatives to compose regexes, you can name and reuse subparts of a regex to create larger regexes. And I feel like that's way nicer. And plus, you get the... You can parse it into the type that you want while you're doing the regex part. You don't have to regex this thing, give me back the matching groups. What's group 1? Convert it to an int. What's group 2? Make it into an enum. Whatever. You kind of get to do both of those parts together. So we're gonna need I guess it's text regex applicative. Import text regex applicative. I need what? RE. I'm gonna need a bunch of sim string. I need a way to match. I'm sure there's more stuff I might need. There's decimal numbers in there, isn't there? Text regex applicative. Is it? It's not decimal. Okay. No, show me the contents, please. Am I looking in common, I think? Digit, hex digit, decimal. Yes, okay. So it's in a different module. Oh, all I want is decimal here. Oh, it even has... I've never noticed this before. It has signed. You can optionally have a sign. How does this work? Oh, if A is numeric, yeah, okay. Okay, cute. We're not using that here. No one's pulling negative numbers of red cubes out of a bag. That's very difficult to do. Actually, let's keep looking at text regex applicative for a moment. What else is here that I might want? And basically nothing, which I think is a really nice, in some sense, a selling point for text regex applicative. Is you look at its documentation, and the functions that you need to construct regexes are, symbols, ways to filter symbols. What is msim? I've never used msim. What is this? S to maybe A. So it's like psim, but you don't have to return. Oh. I mean, you can just fmap into the result of psim, can't you? You can, but okay, maybe that's sort of a partial function sort of thing to do, and msim is the cleaner way? Sure. Okay, fine. So, but anyway, my point is, you just need, a way to say, here's one symbol. Here's a way to, discriminate symbols. Here's a way to say, I don't care what the symbol is at all. Really, all you need is any sim and psim. I think all the rest of this stuff is not really necessary. It's just niceties. And the rest of the things API is like, oh, well, it's an applicative. It's an alternative. You can do all the stuff you're used to doing with applicatives and alternatives, and that's how you compose this stuff. I think that's really nice. It makes it clear that this is some sort of like good abstraction for producing regular expressions. And we're going to want many of these functions. You know, we'll want or, we'll want some, I think. I always end up having to implement sepby, which seems like quite useful for these text processing cases and isn't included here, but like, fair enough, why should it be? Anyway, so I'll keep this page open to refer to as like, in case I forget how to work with applicatives, but I think this is about all I need. Oh, do I need psim? Maybe I actually want msim. No. Because, yeah, I don't think I need either of those. I'm going to be matching like one of several strings to parse red, green, or blue, but I won't need one of several characters, which is what msim would give me. Okay, so let's also say then that type regex is re reg of a is an re char a. So parsing a stream of characters to produce an output. This is the type that we'll call it parser. Why not? It's not really a parser. It's a regex. It's a lexer. But that's all we need. So what we want then is we'll just write some parsers for things we'll need, and then we'll combine them, and it'll be great. I don't have to have a specific plan in mind. So let's have color be a parser for colors. And color, we're gonna need asum. Thanks for the reminder. Who was that? What was that person's name? To be announced. Hopefully I would have remembered it for parsers at least. Where is that date control applicative? Actually, is this in scope? No. Okay. Oops. I didn't mean to say B. Excuse me. Very rude. We'll probably want this at some point. This is the alternative combination. It's or, basically, A or B. We'll want this probably for our parser. Color is a sum of and then we're going to write a parser that ranges over all the colors, basically. We'll range over the colors. For each one, we'll produce a parser that parses just that color, and then we'll combine them into a parser that produces whichever thing it happens to see. So color is an asum over C, like that, over string of data char is probably where 2 lowercase is, right? Let's see. Single case conversion. 2 upper, 2 lower. Yeah, okay, so these just apply on a single character. I have to do the mapping myself if I want to do it for a range. Or for a list. String of map. I have to import it, of course. Import data char of 2 lower of show of C, I think. where C is drawn from min-bound, max-bound? Is that, do you think that type checks at all? Let's find out. It does. Yeah, it's complaining I'm not using all of those all these imports, but I'm planning to. That's fine. Let's actually do one more thing with colors first. Well, I don't know, not with colors. Let's just say range takes enum A and bounded A to give you a list of A, and range is just min-bound, max-bound. And then we'll just say range here. So this type checks, but of course we haven't asked, is it correct? So let's try that. Equal tilde color of red. It was red. You know, and we could say blue, and then we could say bloof, and it's like, no, that is not correct. So great, that's what we wanted. We have a parser for colors now. Interestingly, this isn't even really a parser specifically for colors, right? It's a parser for anything bounded and stringable that parses them as lowercase. And I'm just artificially constraining it to color because that's the only thing I want to parse that way. That's kind of funny. Bounded, enum, and stringable. Yeah, sure. I mean, I could give it that more generic type, but it's nice, actually, I think, to have color be more specifically bound to colors. So asum, I mean, we talked about at the beginning of the episode, but what's up with this parsing? So this function here says, you know, parse according to the parse rules on the right, but the value that you get from that, throw it away and use this as the value instead. Use C. So if you successfully parsed, C should be the value of that parse. And we just say, I have a string, which is the lower casing of how this color is printed, and try to match all those characters exactly. If so, great. We define such a parser for each color by using the variable C to represent the color from the range of all colors. And then asum says, oh, just try all of these, and the first one that works, that's your parser. That's the parsed value. So great. What else do we need to parse? We kind of need a poll, right? Is like a parser for polls. Actually, before I start on this, let's write some parser. Let's move range. I never quite know style-wise, like, how people like to interleave their definitions of types with things that use those types. Like, to me, it seems nicer to put the parser stuff in its own section and some utility stuff, like, or some, you know, before I get into parsing, define all the stuff that doesn't really depend on parsing, right? Even though it means interleaving type and value definitions. I don't know what the right Haskell style is. That way makes sense to me. So I want to write sep by is, oh, you know what? Let's defer writing that type just now. So sep by sep. No, hang on. What order should this be in? P sep by sep is let's see. It's parse P, but do that. I'll tell you in a second. Many instances of sep, and then p again. I think that's right. So this is how to parse, like, the idea here is if I say, oh, I have polls separated by commas, then we should parse one poll and then any number of times, comma followed by another poll, basically. How does this work? Well, this is, I mean, I don't know. Is lift a better way to do this than the applicative operators? Maybe, but whatever. So this basically, a lot of the angle bracket stuff you see in Haskell is like, it's used for applicative stuff. So this says parse p, and also parse many instances of sep followed by p, but throw away the separator and just keep the p. You can see how these two operators are related, right? This is, you know, parse the thing on the left and the thing on the right and like keep them both. And this is parse them both, but keep the thing only on the right. And there's a symmetric one that just points left. So parse both of these, but then keep the one on the left. Having parsed both of those, call the cons function on the result of those two things. So cons the first onto the rest, which is a list. So what is the, many? That's in applicative, huh? Or it's not in base or anything? Okay. Well, surely it's here. Perhaps you meant to add any to either applicative or text regex applicative. Indeed, I did. Okay, and now it says, hang on, there's no type signature here. But let's just ask what the type is. Great. Alternative f to f of a, f of b, f of list of a. Sure. So now I can figure that out myself. And we need alternative here. Let's actually not be a weirdo and let's put this at the front. So sep by has type when f is alternative, it takes an f of a and an f of b and returns an f of list of a. Is that correct? Yes. So this sep by function is named after the one in parsec, which is, you know, Haskell's oldest and most well-known parsing library, and still perfectly serviceable, but these days the kids are using attoparsec or megaparsec or something. One of them is a very small parsec and the other one is a very large parsec, and I don't know what the difference is. I just use parsec because I don't have enterprise needs. But parsec is too powerful, right? A full parser, I mean, I think it's even capable of doing context-sensitive parsing, not just like context-free parsing. I think it's like maybe equivalent to a Turing machine, which is way too much. When you only need a regular expression, I'd rather use a regular expression library, and it's nice to have one that, you know, uses applicative as its interface, but that means you can't use the setby from parsec. So now we can say poll is a parser for poll. And poll is, let's go look at data map again real quick. So union, okay, is there like a way to get unions? Yes, unions with, perfect, yeah, so I want unions with, I have a list of maps, and I want to combine them into one big map. Okay, great. So let's go add that to our import list here. Oh no, I imported all of it as M. Great. Poll is m.unions with plus mapped over no. I don't like this. First, I need a way to parse a single poll of one color, a number and a color. One color poll. Is, let's see, what does our input look like? Color and then, sorry, number and then color. Go. Wait, you don't know what to name a function? Call it go? You'll figure it out later. Go of decimal, and then let's do something else simple. Space, parser for unit, space is unit over sim space. I have sim, right? Yes, okay. So I could just write sim space here, but it's like, I don't know, I'd rather just write space. Decimal space, and then color, where go of num c is m dot singleton, that must exist, of the key here should be the color, and then the num, right? Does that type check at all? Oh, hang on. Am I in the middle of something? I don't think so. Yeah, I changed. Okay, yeah, this should work. No. One color poll type signature lacks a binding. Oh, I must have spelled it wrong? Yes, one of them is lowercase. Go has the wrong type. Uh-huh. Oh, you're... Map for parser of colors to int. Hang on. Oh, that's... something's wrong there. So decimal is a parser. Space is a parser. Color is a parser. So what is it you're telling me? I have a map of color of parser somehow instead of a parser for map of color? Okay, maybe I need some parentheses somewhere. I always get kind of confused about when you're mixing these two. Okay, so maybe I'm just supposed to do this. Nope. What's wrong here? Oh. No, I don't need to say pure. Go is f-mapped into this. A poll is a map from color to int. I have a parser for an int and a parser for color. Oh, color. Oh, it should be C. Color was referring to this global parser color. That's what's wrong. Yeah, that's fine. Okay. And now let's get rid of these silly parentheses I put there because I was confused. Yes, okay, good. So we can test this as well. We can say one color poll of, for red. Nope, not, well, good. Yeah, so there you go. It says, oh, it's a map, and its key value list is just one thing, and that thing is that there are 4 reds. That's exactly what we wanted. And if we said there were 45 reds, yep, parses that too. Thanks, decimal. Okay, great. Now we can maybe say pull is also a parser for pull, but it's like all of them, right? Pull is m.unions with add them up over pull sep by string comma space. Is that right? I think that's all. Let's see if it type checks. Yep. So now we can say, let's test pull with 45 red, 3 blue. Uh-oh. Uh-oh. It's not going. It's unhappy. Why? Pull set by string, comma, space. Try again? Was it just confused? Doesn't look confused. It looks like it's thinking very hard. Huh. Well, what's wrong with that? Okay, I guess one thing to think about is what if I just did this? So is pull... Oh, did I not reload or something? No, I did. Oh, pull... One color pull. It was recursively calling itself and not making any progress. There you go. It says, there's 45 reds and 3 blues. And if we ever happen to say that there were like another 9 blue, this won't be in the input, but it works. It adds them up. Really, I mean, we wouldn't even need unions with the way the puzzle input is given to us, because there's only 3 inputs, at most 1 of each color. But just in case he said, I pulled 2 blue and then another 2 blue, now we handle that as well. Isn't that nice? And now I think we're about ready to write a parser for game, are we not? Game is... game... a decimal, and then ignore string of colon space. And then there's... let's see. Pulls separated by the string semicolon space, I believe. Is that type check? Yes. So now we're ready, I think, to... how do I want to do this? Go look at the input. Let's grab this. It fits on one line. And say... parse this as a game, please. No instance for show game. Okay, fair enough. Let's put that in, I guess. Nothing. Doesn't parse. Great. Okay, we learned something. Oh, of course. We didn't parse the string game. Yeah, so now I think I need some parentheses. So, like that, maybe? Yes, that parses. or it compiles, type checks, and this now actually parses. It says, oh, this is game 7. First you drew a red, 6 greens, and 15 blues. And then you drew 2 reds, 7 greens, and 4 blues. And then you drew 2 reds, 5 greens, and 14 blues. Perfect. That's what we wanted. So our parser is complete. And, of course, as predicted, it is many times longer than whatever parsing code you would write in Python or JavaScript or Java or whatever, right? But it's much more composable and understandable, right? And you're working kind of at the domain level the whole way. You're not like working at the level of strings and regexes, really. You're saying, here's how to parse a domain concept, here's how to parse another domain concept, here's how to combine multiple parses. You're not saying, here's a big old string that is like my program encoded in some weird programming language, and then I need to post-process that string to turn sub-pieces of it into my domain objects. So I just find this kind of parsing beautiful. And I think it's better for maintaining large systems that include parsing than a regex-based approach. It also is actually regular, unlike modern regular expression libraries, which allow you to do, to recognize non-regular languages. And as a result, it can be fast. It doesn't ever, It uses the theory of regular expressions to do things quickly instead of like just getting a bunch of bloat, because the regular expression string standard is whatever. Stop complaining about regexes. I have a bee in my bonnet about this stuff. You can tell. Okay, so now we're about ready to write prepare. Prepare is to... is there like some... Well, let's just say it's map maybe of equal tilde game lines. So, right, and we need map maybe from data maybe. This type checks. Great. So this is a little bit like iffy because we're just kind of throwing away games that don't match, but that's okay. They'll all match. It'll be great. And just out of just to double check, how many games do we get if we say stack run? How many games parse? There should be 100. Oh, we ended up not needing that or, huh? Uh-oh. Okay. It was still building. I thought it was just taking a really long time to run. Okay, yeah, so it takes 100. That's how many we get. Great, so that's what we wanted. And I guess I'll throw away this. I thought I would want it at some point, but turns out the higher level concepts in the applicative were enough that we didn't end up needing that low level combinator. Okay, so how do I mean, like, so what we want to do is it's the sum of filter possible, where possible is a function of game, right? Where possible is a map applicative? That would be interesting, wouldn't it? It seems like it should be a zippy applicative, right? It's a functor. I don't see applicative showing up. Why not? Okay, but okay, maybe there's some way to combine maps. That's interesting. Yeah, I don't have. I want like. I can combine a bunch of maps by using max, and I'll do that. But I kind of want to say, is this map less than that other map? Which is the kind of thing I could do if map were applicative, but it's not, presumably for a good reason. I guess because pure is kind of awkward. Yeah, fair enough. I don't really want differences. Intersections? Intersection width? I mean, I guess this is sort of just union width, right? Disjoint? What the heck? No, I don't want that. Compose. Oh, wild. Okay. Is it possible I want to traverse a map? I don't think I do. No. I don't need any of these weird folds, I don't think. Filter. No. I don't need any submaps. I don't think this is right. Oh. Look up min. Oh, this is for... Yeah, that's not what I want. Yeah, it mentions min and max, but it's talking about the largest and smallest key, not value. Okay, fine. Let's actually also... Before I call possible, let's just map of... Combine? I don't know. Where combine... Oh, we're going to want this part 1 and part 2, I imagine. Let's say combine is a function from... It's annoying that I can't... The game isn't a functor, but, like, it obviously shouldn't be. Let's write a little function here that ignores the int in the game number. Map game takes a function from list of poll to... Well, it's kind of stupid, right? List of poll. There's only going to be one map game we're ever going to want to do, right? So let's just define that as the top level thing, I guess. Combines a function from game to game. Combine of game ID and polls is a game ID, and then over the polls, I want to do m.union with max. Unions with max over the polls, I think, right? Oh, I guess I want... Where's my game type? Here it is. I mean, I want an accessor for just the game IDs, right? So git is an int. I don't want to use id because that's a defined thing. I want to call this polls, but don't I already have something called polls? No. Here I'm shadowing polls, but that's okay. Well, I don't know. Maybe I can just G is game of gid G and polls G. Like, this is a little bit inefficient, but list of poll. Oh, true. I turned a list of polls into a single poll. That's... Maybe game actually should be a functor? So I could have a game and information about that game. That sort of makes sense now that I think about it. And it would save me all this work I just did. And having to do any of this shit. So what if I just said a game of A is a game of int and A. Where do I mention games? There's a parser for games specifically listing just the polls that happened. Combine then takes a game of list of poll and produces a game of a single poll, which is the most we know. Oh, but now it doesn't even really need to be its own little function, right? It can be part of part 1, and then we might not use that in part 2. We can say combine is fmap, i.e. reach inside the game. Oh, we need to make it derived functor, please. That's probably already included in my language pragmas. Guess we'll find out. So it's fmap, reach inside the info about the game, and fmap m.unions with max, I believe, right? Is that all I want? I thought... So here's the thing I don't understand. I am looking at my Cabal file, and I say, I want my default language to be Haskell 2010. I don't really know what default language means, but I think it means, like, whatever Haskell 2010 is, pretend I wrote pragma, like, language Haskell 2010 at the top of every file. Does Haskell 2010 not include deriving functor? Let me look that up, I guess. Haskell 2010, like, list of extensions or something? This is the language report. Derive. No? Maybe not. Okay. Fine. I don't know why my template has these on multiple lines, by the way. I wrote the template, but like I disagree with myself. Okay, so does that part compile now? Almost. Yeah, we have a game of map of color event, and we're expecting an int. That's true. But the part that I just edited, I believe, does type check. It's this thing at the end. I just need to like map did of game G is G. Let's just find this at the top level as well, I guess. Game of anything to int. That type checks, great. I don't know. If I just turned on lenses, I could derive these lenses, but I don't. It's very heavy machinery for this tiny little task. It's swatting a flea with a nuclear missile, right? A fly, rather. It's the... Okay. So now all we need is possible. Which is... I have a game, and I figured out what the minimum possible number of all the things is, and I want to say, you know... Well, I guess what I can do is say, all right, if we say, I don't know, limit maybe is m.fromList of what are the limits the program is allowing us for. So we are only allowed red 12, green 13, and blue 14. That's the most we're allowed to have. And I think we can just say that possible is of any game and a poll is if m dot union with max of p and limit, if that is equal to limit, then nothing... why did I put max in parentheses? I guess I'm used to writing plus there. Union with plus or something. Or from list with plus. Anyway. If the union with max between p and the limit is the limit, then nothing in p was above the limit, right? I think that makes sense. Let's run it. $3,059. Let me double check before I enter that I was calculating the thing I was meant to calculate. If you add up the IDs of the games that would have been possible. Yeah, that sounds right to me. The number was 3059. That's the right answer. Great. So let's commit that, and if there's any cleanup to do, let's do that before we look at part 2. Get diff. I mean, it's just going to be the whole file, right? Oh, I guess aside from the templating, the scaffolding. I think this makes sense. I could have committed when I just had the parser done, I suppose. Yeah, this looks fine. I don't see anything in here that I'm dying to change. Day 2, part 1. All right, great. And back to the website. They stopped producing snow because they aren't getting any water. Oh no, he isn't sure why the water stopped. He can show you how to get to the water source. Check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been used in the bag to make the game possible? Oh, this is just easy. Okay. The power of a set of cubes is the number of red, green, and blue multiplied together. The power, okay. Great. So we did all this work already, pretty much, by actually maintaining the max rather than checking whether any number was less than or greater than the actual limit. So it turns out we will want combine in part 1 and part 2. I mean, that's not a huge surprise, I guess. But I wasn't sure. Combine game list of poll to game of poll. So part 2 is sum.map power map combine, right? This is actually easier than part 1, where power of... It doesn't care about game IDs anymore, right? The sums of the powers for each game. Yes, okay. Power? Let's try spelling it right. Power of game, ignore the ID... P is... Oh, it's just... You don't even care about which one's red, which one's green, which one's blue. Just multiply them all together. Oh, easy. Product... Why can't I spell? Product of... Well, product of m dot elms of p? Like, that's it? Compiles. Run it, please. Should be a big number. Okay, I'll believe it. Yeah, easy. Okay, cool. So this is sort of what I regard as a successful advent of code where I, did all the domain modeling and work necessary in part 1 that part 2 was just like, oh, apply a different filter, ask a different question about all the data you have. You don't need to gather any new data. And part 2 is so much easier than part 1, right? Because we're doing like all the work already. Why do I have... Oh yeah, this function, I guess I could have put this into part 1, I guess. Turns out we didn't need the game IDs for part 2. Fine. Let's do that. Just double check there's nothing weird that I accidentally got in here. Hello? Okay, there we go. So we took combine and made it top level and git and snuck it into part 1. And then we implemented part 2. Yeah, that looks right. A2 part 2. All right, I'm happy with that. I think we're done here. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.